Hello everyone, in this video I am going to explain you how to solve this week 1 assignment for our NPTEL course C programming and assembly language. So the first question is, what are the contents of our AX and the BX register after executing this set of instructions? So the first line is move x, 0x06. So here we have written this 0x06. So this 0x indicate that is the hexadecimal value, and this 06 indicates that is the actual our hexadecimal number that is written after this 0x prefix. And the base for this number is 10. Now what we are doing here, we have to execute each and every instruction, and after executing this all set of instruction, we have to find out the contents of AX and the BX. So the first statement is move AX, 0x06, and our output will be AX is equal to 0x06. So the contents of 0x06 will be copied into AX register. Now the next statement is move bx, 0x04. Then the contents of 0x04 will be copied into bx register. Now the third statement is add ax, bx. So now we have to add ax and bx register. So whenever we are executing this add instruction, the result of the operation will be ax is equal to ax plus bx. So we have to check what are the contents of our ax and the bx. So the contents of ax is 0x06 plus we are adding this 0x04. So after addition, it will become 0x10. But 10 we can write in hexadecimal value as 0x08. So these are the contents that are updated in our AX register. Now we have to check what is the next instruction. So the next instruction is XOR BX, BX. So we are writing here XOR BX, BX. And we have to check what is the contents of our BX previously in that instruction. So the contents of our BX is 0x04. So I am writing here XOR then 0x04, 0x04. So now we have to perform this XOR operation. So these are the truth table values are there, that is 00, 01, 10 and 11. If both of the operations are same, conditions are same, then we are writing here 0. If one of the condition will be different, then we are writing here 1. So you already know this truth table for the XOR operation. So now we have to perform this XOR operation with 0x04 and 0x04. So our answer will be 00. So we will check how we can identify this answer. So first of all, this 0x04 is nothing but 0000, 0000, and again 0000 and 0100. So this is the first number I am writing here. Now I am writing this second number here, that is 0000, 0000 and so on. And we have to perform the XOR operation for these two numbers. So this all the cases are same in the first and the second one. So we got this output is 00 all time 0. So whenever we have to write this answer in the prefix format, then we are writing here 0000. And this result will be stored in our destination register, and our destination is BX register. So I am putting here BX is equal to 0x00. Now we have executed our XOR operation. The last instruction is subtract AX, BX. So I have to write here subtract AX, BX. So after executing this subtraction instruction, the result of the operation will be AX is equal to AX minus BX. Now we have to check what are the contents of our AX and BX. So here the contents of AX is 0x0A. So I'm writing here 0x0A minus our previous contents of BX will be 0x00. So after performing the subtraction, we will get the result as 0x0A, and this result will be stored into our AX register. Now we got this output for AX variable, that is 0x0A. And our question, what will be asked? We have to identify the value of AX and the BX register. So here there are two options will be there. The first one is AX is equal to 0, X10. Sometimes you can identify 6 plus 4 is equal to 10 and you can select this option. But this one is wrong. You have to select this option like 0x0A for AX, and the contents of our BX will be 0x00 that we got here from our XOR operation. And for the subtraction, we got the contents of our AX. Now here we got our two values, that is AX and BX. And we have to select the option, that is D. The next question is we have to identify which flag will be set after performing this instruction. So which of the following flags are set and the value becomes 1, we have to identify. So assume that these are the initially all flag will be set to 0. So the first instruction is clear direction flag, that is our CLD instruction. So whenever this CLD instruction will be executed, our direction flag will be set to 0. So CL indicates that clear and D indicates that our direction flag, and this will be set to 0. The next instruction is move bx, 14. So our value of bx will be 14. So I'm writing here bx is equal to 14. We can write it as 0x0e. Now the next instruction is move ax, 10. So our contents of ax will be 10, or we can also write it as 0x0a. This one is executed. Now we have to perform the AND instruction. So AND AX, BX. So I'm writing here AND AX, BX. So whenever you are performing the AND instruction, that time we have to check if both the cases are 0 and 0, you got the output 0. If it is 0, 1, then also 0. If it is 1, 0, then also 0. If it is 1, 1, then you got the answer 1. If both the cases are true, then you got the output true. Otherwise, it is false. Now we have to check the contents of our AX and the BX. So I'm writing here and 10, 14. So whenever you are performing the operation with our 10, 14, then what will be your value? Suppose consider that I'm writing here 1010 for 10 and 1110 for 14 and perform the AND instruction. So I'm writing here 0 into 0, 0, 1 into 1, 1, 0 into 1, 0, and 1 into 1, 1. So I got my output, that is 1010. So this is our 1010 and we got the output 10. So the contents of our destination will be updated and our destination register is AX register. So my contents of AX will be 10, or we can write it as 0x0A. Now we have to check the next instruction, that is move CX, AX. So I'm writing here move CX, AX. So whatever the contents we got previously in the AX register, that will be copied into our CX register, because CX is the destination and AX is the source. So the contents of our AX will be 10 and that we are copy into our CX register. Now, what we have to do? We have to perform the next instruction. So, the next instruction is subtract ax comma bx. So, here I am writing subtract ax comma bx. So, now ax is equal to ax minus bx. So, we have to check what are the values of our ax and bx. So, my contents of ax will be here, that is 0x0a, and the contents of bx will be, that is 14, that is 0x0e. So whenever you are performing this 10 minus 14, you got the negative number, that is minus 4. And for this minus 4, whenever you got the negative result, that time your sign flag will be set to 1. Now the next instruction is add cx plus cx comma 4. So I am writing here add cx comma 4. So we have to check what is the contents of our cx, and cx is equal to cx plus 4 will be done, and in the cx our contents is 10. So I am writing here content 10 plus 4, that is 14, and our cx register become 0x0e. Here there is no negative sign, there is no flag will be set. Now next one is compare bx comma cx. So I am writing here compare bx comma cx. Now what is our contents of bx and contents of cx? The contents of bx is 14 and the contents of cx is also 14. So I am writing here compare 14 comma 14. In compare instruction, there are three conditions. We are checking the destination is greater than source, the destination is less than source, and the destination is equal than source. So this condition is true because our destination and source both are equal. If both are equal, then our zero flag will be set to 1, sign flag will be set to 0, and our carry flag will be set to 0. So here we got the output, that is 0 flag will be set to 1. So after executing all this instruction, which flags will be set? We got the output, that is 0 flag will be set to 1. If you are executing all this instruction, then after executing all this instruction, you have to check which flags will be set. So here, whenever we are executing this instruction, that is subtract ax comma bx, we got our output, that is sign flag will be set to 1. But whenever we are going for this instruction from this compare instruction, that time these both values are equal, that is bx and cx will be equal. When both the values will be equal, then again our sign flag becomes 0. So the answer for this question is only 0 flag will be set, and the answer for the question is only D option. You don't have to select this sign flag option, you have to select the option only D. So whenever the question will be asked in the exam and the flags will be asked, that is direction flag, overflow flag, sign flag, and the 0 flag. So here direction flag will be set to 0 here. Then overflow flag is also set to 0 because there is no overflow happen in this instruction. Here this sign flag will be first of all set to 1, then it will clear to 0 once you are performing this compare instruction. So I am writing here sign flag is equal to 0. And our 0 flag will be set to 1 after executing this last line of our code. So the answer for this question is 0 flag will be set. So when you are going with that emulator screen, and if you are writing all this code, then you will get the output for this code and you can check what are the flags will be set here. So here you can check this 0 flag will be set and this sign flag will be set to 0. This direction flag is set to 0 and our overflow flag is also set to 0. So you can definitely write this answer that the 0 flag will be set to 1. The answer is D. The third question is, we have to consider these two cases, that is case 1 and the case 2. This is our case 1 and this is our case 2. And we have to identify the values of CL will be same in the both cases. We have to write down the true and the false. So how we can identify? So whenever you are executing this instruction, in that first case, what is the instruction? Move ECX, 02. So the contents of our ECX will be 0, 2. Then here we are executing this clear direction flag, that is direction flag will be set to 0. So this is the instruction, that is the repeat instruction, and we are writing here move SB. So whenever we are executing this instruction, your value of SI and DI will be incremented by 1 and value of our counter will be decremented by 1. So this will happen whenever you are executing this repeat instruction. And the contents of AL will be copied and that is 0, 2. So this part is same and this part is also same in the second case. But what is the difference between these two cases? So here we are writing repeat move SB and here also we are writing repeat move SB. So here both the statements are equal. And here, whenever we are decrementing the counter, that counter will be decremented by 2 because we are executing this instruction and our counter will be set to 0, 2 in both the cases. This counter is set same in the both the cases and it will be decremented 2 times whenever we are performing this repeat move SB instruction. And it will become 0 in both the cases. So our ECX becomes 0x00 and that is the final value in both the cases. So we are writing here the answer for the question is true because the value of CL will be same in both the cases. Now the fourth question is, find the value of DL in decimal after performing the following instruction. So here the EAX contents will be updated with that content, that is 0x and 8 times F. So I'm writing here EAX and 0x FFFF and again FFFF. Now the contents of EDX will be 5 and the contents of ECX will be 2. And here we have to perform this MERL instruction. So what is this MERL instruction? That is the multiplication instruction and we have right here MERL ECX. So in that MERL ECX instruction, what we are doing? We are doing, that is AX is equal to DX colon AX divided by multiplied by CX, that is ECX. So what is the contents of our ECX? That is 2. And what is the contents of our AX and DX? That we have to take. So here the contents of DX is 5 and the contents of EAX is 0xFFFF, FFFF, that is 8 times F is there. So when you are considering this value, that is FF 8 times F, and we are writing this number in decimal number, that time you got the answer, that is 4294967295. Whenever you are converting this value into decimal value, and you have to perform the multiplication of this number into 2, and you got the result after multiplication, that is 8589393459. That is the value in decimal. So why we are taking this value in decimal? Because what is the question? You have to find out the value of DL in decimal after performing the instruction that is given in that example. So now we have calculated the mul ECX instruction. So the contents of our AX will be updated here, and the contents of AX of this one 8589934590. So whenever I am writing this number into hexadecimal, that time we got this number, that is 0x1 8 times F, then E. So you can convert this value into hexadecimal, you got this output. So now we have to store this result as dx colon ax. So this value will be stored into dx colon ax because we have this number as a 16-bit and 16-bit number. That is dx colon ax become the 32-bit of number. So this value will be updated here, and the data will be stored into dx colon ax. So the first lower byte will be stored into edx, and the next lower byte will be stored into eax. So 32-bit of lower order data will be stored into edx variable, that is edx register, and the lower order 32-bit of data will be stored into eax register. So here, whenever you are storing the result into AX register, that time you got the value, that is FFFF. This result will be stored into our AX register, and this part will be stored into our DX register. So the contents of DX will be 0x01, and the contents of AX will be 0x, then FFF 8 times F, and then E. So now we got the output for our DX. This is the hexadecimal number, and we want the decimal number. So whenever we are taking this decimal number, we got the output, that is 01. So the answer for this question is 01.